Now let's move into something else, like in this case we're using executable wrappers. Now instead of creating malware from scratch, as you hopefully wouldn't have to do, right, it's of course much quicker for an attacker to use existing malware and combine it with a benign game or program. So executable wrappers here have the ability to combine two or more programs into a single file. When the wrap file is run, guess what? Both pieces of the binary code are run, thus installing and running the malware. Elite Wrap is one of those tools that would be used for that. It's an advanced exe wrapper for Windows, and it's used for archiving and secretly installing and running programs that we have. Some of those benign exe historically wrapped with Trojans, we have what's called the Whack-A-Mole. And its popular delivery vehicle was the NetBus or the back office Trojan servers. If the Whack-A-Mole gets wrapped, running whackамole.exe installs the NetBus back office server and then starts the Trojan program at every reboot. Graffiti was also another one of those. It was an electronic greeting card that in pure form was harmless, however, can also be wrapped in order to deliver malicious code like your Netcat, for instance, or other ones that you want to utilize for that. Now, when it comes to some of these malware countermeasures and so forth, of course, there's different ways to go about it. Now, the number of tools and actions that can be performed to both detect and hopefully prevent malware, these tools are discussed over the next few slides. And here, of course, we have our antivirus, personal IDS, your intrusion detection system, and personal firewall products. Whatever they may be, again, they may do a good job on helping you protect against different types of attacks. Let's say you have an attack that goes against something, let's say, that executes every once in a while. And so forth. And these would be called what we call the sparse infector viruses. And they basically, they execute on your birthday or something like that, or Michelangelo's birthday, or whatever the case may be, right? So those would be a little bit tougher to find when you're using an antivirus product and you're going out there and trying to locate those because they only execute every so often, right? And so forth. Now, when we look at, for instance, a virus life, right, and we look at the stage, for instance, of, let's say, a stealth virus and what stage it gets activated, and so forth. And a lot of that has to do during the launch side. So basically, once we launch that executable or whatever it is that we're trying to get to, that VBS file or whatnot, once it executes at launch, that's when it starts going through whatever it's been programmed to do, and then we'll start changing your icons around possibly and things like that, which could be considered what's called a defacement Trojan possibly, that will go out there and change your icons around or whatever the case, change some different things around. And hopefully, let's say you're getting an email that you've probably seen before where you get maybe some jokes or whatnot in mail format, right? And then what happens is it's just a virus hoax, right? So the Nigerian thing with the, hey, I have $10 million and so forth, and all you need to do is give me your information, right? Some of those are just virus hoaxes, right? So they're not necessarily dangerous by itself, but some of them, of course, if you act upon it, could be possibly dangerous and such as well. So keep in mind, whenever you get infected with something like this, if you do get infected via email or whatnot, keep in mind it could possibly install screen capturing spyware on the computer and capture screenshots and things like that. And some companies, believe it or not, they actually monitor every employee and so forth with spy cameras, keyloggers, and so forth, basically spy on them. But a lot of that, of course, is legitimate through the use of policies and as they sign those policies and so forth along with that, right? So again, when it comes down to it, just know that a lot of your different types of viruses will be detected through a virus scan. But keep in mind, there are also different types of viruses and so forth that will actually change their code every time they infect. And they're called polymorphic viruses. And they'll basically go through and kind of change and their string, their signature basically with that. So that way your antivirus products won't be able to pick them up right away and do that. Other things too, a lot of times you've probably heard, right, is when it comes to office products and so forth, right, you generally have what's called a macro virus that would be used for something like that. Other than that, what can we say? When it comes to any viruses that are hiding themselves by actively altering and corrupting service calls and so forth, These would generally be considered stealth viruses, and what can we say? Those can also, of course, be brought into play. And what can we say there? Obviously, I'm hoping that you'll have some type of experience with viruses in the past, and it will basically hopefully assist in some of those things. Now, one other place too that you can basically get to look for suspicious files and so forth is going to be in the device drivers section, which is going to be in your Windows System32 drivers folder, and make sure you scan that for suspicious device drivers, which could again be another way you can detect different types of Trojans that way, because they would generally hide themselves in those types of folders and so forth as well. Okay, now other things you could do is, of course, anti-spyware and Trojan products, obviously, port and process monitoring software such as Fport, TCP view, and such, which are great little tools that will go out there and do things. Of course, registry modification detection using tools like Hijack This, for instance, will also be pretty interesting to use out there in the field, right, when you're checking that out. But when we talk about registry setting entries and so forth, a lot of times too we're talking about rootkits and so forth. Now the rootkits are a whole nother level of things, and they're far more dangerous. Now in general, rootkits will be at the kernel level, but there's also other types of rootkits available. We have hypervisor level rootkits. We have, of course, the kernel level, which has always been that way. And then, of course, also the application level rootkits that are out there. And the rootkits will do far more damage to your operating system files and so forth, because they will require change of those system files and so on. And when you do that, you basically have to use different types of tools to check for that. And those are coming to be your system file integrity tools like Tripwire. Definitely a good one to remember. And it does a really good job on that. Now, there are some other tools out there that you can use. Let me show you real quickly again. If we put up our command prompt, so pull up a command prompt, type in sigverif, right? This is the signature verification tool. And this will basically go out there and check our system to see if it has any files that have not been digitally signed and so forth. And I may have mentioned this before, but it is a great little tool that goes out there and checks our files and so forth, make sure we're not infected with something and so forth. Now, I may have mentioned before too is that when you're trying to find rootkits, you generally would need a rootkit detection tool for this, not just an antivirus product and so forth. All right, so actually here we're all good to go. But anyway, some of those things are definitely there. And of course, we also have the different scenarios like having malware reference websites that you can see like Glocksoft, Symantec, and McAfee, and so forth as well. All right. Some other things I want to at least mention here too is that we have different things out there. Remember I mentioned botnets before, right? And we talked a little bit about that in the previous module when we talked about your distributed denial of service attacks and so forth. And we talked about the command and control centers and so forth. And one thing I may have failed to mention is that Poison Ivy is actually one of those command and control centers that could be used for that. I would definitely recommend that you check out some of the different types of rootkits and viruses that are out there. All right, and then here we have one called Gargoyle Investigator, and it's basically an enterprise-based tool. It's a forensic malware investigation tool. It performs enterprise-wide collection of malicious code hashes on multiple targets simultaneously, including a single user license of Gargoyle Investigator Forensics Pro. It has 20 datasets containing over 10,000 types of malicious software. Dataset Creator creates and builds its own categories for detection. It also utilizes created datasets to search for known documents that only you should have access to. It also incorporates with popular forensics tools such as Incase and the Forensics Toolkit, FTK. Timestamped enterprise discovery reports also for each target as suspected is also valid there. Great little tool for real-world analysis. The other great tool is called Fport. And here you notice Beast Trojan running on port 6666 might be something you want to remember a little bit about. To quickly reveal what active connections are established as well as any listening ports, use the built-in netstat command as well. Now when suspicious ports is found, use one of the following tools to map the open port to a running executable. Use Port Explorer, FPort as you see in here, or TCP view, which is another. And what's nice about FPort, as you see here, is that it will actually show you what it's executing from, as in the directory it's coming out of. So if you notice too, if it's coming out of the temporary directory, then that might be something to really investigate into. File protection software, as we already mentioned. File system integrity alerts administrators when critical files have been modified, thus giving early warnings that Trojans, rootkits, and other malware have been installed. These products works by comparing properties of file before and after modification. And one of those properties could be an MD5 checksum, your message digest 5 checksum, which runs at 128-bit. Right, so and some say that it runs at 48 characters as well, which may be an indicator there. All right, the Tripwire and GFI LandGuard SIM are also examples of products that monitor file integrity. Tripwire, important to remember. And here's the again the file signature verification tool called SigVerif, and you definitely would probably need to know what tool to open it up with, as in you would run it from the start command and then type in SigVerif to get that open. So here the Windows File Protection protects operating system files from being overwritten. If a system file is overwritten during software installation, the Windows File Protection Service immediately copies back the original file. The hashes in the file then are compared with the SHA-1 hash, which runs at 160-bit, by the way, in the current system files to verify their integrity against the factory originals. Now, we also have another one. This is the software restriction policies. This is a set of rules to control the software programs the user can run, also known as whitelisting. And a user may be able to download malicious files or receive it from email, but a properly configured software restriction policy will prevent the malware from even running. There are 4 categories for the rules. You have your hashes, meaning that it won't actually execute the executable that you're trying to execute unless it has a specific hash value. Certificates, which is another great way to do it. File path, meaning that it's only going to run under if it's from within a specific file path, or if it's within the internet security zone that you set up. Recommendation is that you create a hash rule to allow all known apps and then set the default policy to disallow. Know that the software restriction policies are only for Windows XP in 2003, not any versions below that, like Windows 2000 or below. And of course, with your newer versions, 2008, 2012, and so forth also. Good stuff, as in it will work there. Okay. All right, now let's take a quick peek here when it comes to buffer overflows and so forth. Now, with the buffer overflow section, here we basically have a couple of items there that you may need to know a little bit more about. And we'll actually mention a few of those, and then we'll move right on. There's not a whole lot that comes up when it comes to buffer overflow, but just know that is a condition exists when a program attempts to put more data in a buffer than it can hold, or when a program attempts to put data in a memory area past the buffer. In this case, a buffer is a sequential section of memory allocated to contain anything from a character string to an array of integers. Writing outside the bounds of the block of allocated memory can corrupt the data. It can crash the program or even cause the execution of malicious code. Pretty sweet thing. Now, back in '96, European Space Agency Ariane 5 rocket exploded right after launch because a program tried to put in a 64-bit number into a 16-bit memory space. So here's an overflow illustration. So a basic example of buffer overflow. So by writing 10 bytes of data into A, which only has 8 bytes available, B in this case is then changed unintentionally. Now, when it comes down to buffer overflow type stuff, there's generally going to be different things that come into play. And one in particular way to do it is doing what's called the no-op sled. And basically, no-op sled is one of the oldest and most widely known techniques for successfully exploiting a stack buffer overflow. It solves the problem of finding the exact address of the buffer by effectively increasing the size of the target area. Now, to do this, a much larger section of the stacks are corrupted with the no-op machine instructions. The end of the attacker supplied data. After the no-op instructions, the attacker places an instruction to perform a relative jump to the top of the buffer where the shellcode is located. Now, the collection of no-ops is referred to as a no-op sled because if it returns the address is overwritten, any address within the no-op region of the buffer will then slide down the no-ops until it's redirected to the actual malicious code by the jump at the end. This technique requires, however, that the attacker is to guess where on the stack the no-op sled is instead of the comparatively small shellcode that's out there. And again, when it comes down to this too, a lot of times you're going to see this here. Let me bring this up. So what you're going to do is whenever you see anything there, it's going to look something like this as well. All right, so you'll generally see anything related to kind of a buffer overflow type scenario might be something like this, where you have the shellcode, and then, you know, I don't know, something like that. And then a whole bunch of hexadecimal whatever representations that we have there, right? So something like this. Right, and basically if we had, for instance, something like this, right, and we brought that out a little bit, right, it would sort of look like that. So if you happen to see something to the effect like this, and anytime you see a result or whatnot that has to do with a whole bunch of hexadecimal numbers and so forth, you can just definitely say it would be buffer overflow. Now when it comes to the no-op sled instruction, the hexadecimal value is going to be your X90 value, and again, it's pretty cool. Now when writing shellcodes, you must avoid using null bytes, because the null bytes will actually end the string altogether. So also another thing to maybe look into there. Now buffer overflow attack, of course, is generally going to be attempted whenever we see something like this. And also what you can do though, if this can also be done on a web site side of it, as in web server side of it. So you're basically seeing this, but you're seeing maybe more a web link along with it. So what you can do is you can actually set up, because keep in mind we can also use different Unicode and so forth, but you can set up a rule within your IDS to check for those strange Unicode requests and so forth as well. Because again, it all comes down to being able to provide, again, some type of filter that we can then look into and look at when it's all said and done there. Now a lot of times programming languages that are going to be most vulnerable to buffer overflow attacks are going to be like your C++ type scenarios. And again, it allows us to create those types of scenarios. So again, anytime we see what I've just showed you here would indicate a buffer overflow type of issue there. Now, anything else here we want to mention at this particular stage? At this time, I think we're good to go there. So I'm going to continue on, and we'll take a look at some other options here that we have available then for us, okay?